So before watching this video, hopefully you already learned how to use ODE 45 to solve first order ODEs. Um, in this class, we're most likely to solve second order ODEs, or in your future career, you might want to solve nth order ODEs. But all these higher order ODE equations can be easily converted to first order ODE. So if you took my ME 380 class, so you might already know that. If not, so the concept is called the state space representation. What does that mean? So a state, for example, in our case, depending on how, like for example, if we have a second order ODE, how many states you need to use to describe the motion of an object. So the idea, for example, if you have a mass, in order to describe its motion, we just need to describe its current position and also its current velocity. Once we know that, then we can say, okay, the motion of this object is fully defined. So these x and x dot, we call them states. So what we do, so we assume that we create a state column vector y, and then x dot velocity and x. So that means your y vector has the states of your object. Okay, so let's see what these y single dots look like. So a single dot is just time derivatives for each entity. Your x dot becomes x double dot, and then x becomes x single dot. Okay, so then we need to describe your y dot. Describe y dot using y, or describe x double dot x dot using all the state variables x dot and x. So let's look at the first equation. Your x double dot, we need to use x dot and x to describe x double dot. So that's why we have to go back to the original equation. It's just minus zeta 2 omega n x dot minus omega n square x. Okay, how to describe your x dot using these state variables? As you can see, that x dot is simply x dot. You don't have to change anything. So eventually you have two equations. On the left hand side, you have the y dot column vector. On the right hand side, you just need to reorganize your coefficients. Let's see how it looks like. Your y dot equals to x double dot x dot, and then on your right hand side, you can easily write it as a multiplication, x dot x, and then you just copy, you just copy in all the coefficients. Okay, so let me know if you have any challenges converting linear equations to matrix format. You should already learn this in your linear algebra class, or perhaps in other classes, but if you don't know, let me know. Okay, so as you can see here, we define these 2 by 2 matrix as matrix A, and then as you can see, the x dot x column vector is just simply y, and then y dot equals to a y. As you can see here, that's the first order ODE. So that means if you have a second order ODE, then you can use this state space method to convert it to a first order ODE. This method also applies to higher order ODEs if you're interested.